What if your endpoints could automatically disrupt a threat as soon as it's detected? See the demo on today's Tanium Tech Talk. Welcome back to Tanium Tech Talks. I'm your host, Ashley McGlone. At Tanium, we are constantly innovating to help arm security teams with tools that make their life easier. And we're also on a quest to increase automation for SecOps processes. I mean, think about it. You get an alert, you investigate, you collect forensics, you take action, but how much time could we save if that were automated? And we know there's some things out there that kind of do a little bit of that today from what we're going to look at, but imagine taking that a step further. And what if you could dynamically disrupt attacks on the endpoint as they happened? So our guest today is Thomas Aiken with over 20 years in cybersecurity expertise. Welcome to the show, Thomas. Tell us a little bit about yourself.
Thank you, Ashley. Thomas Aiken. Before I joined Tanium, I did about 20 years of incident response and computer forensics. I joined Tanium about 8 years ago. And if you don't mind, I'm going to dive into my story there a little bit. I joined Tanium immediately after I saw it because of the platform and its capability in incident response. I was tired of spending days at Fortune 500 companies just waiting to figure out what endpoints had vulnerable applications on them, or what endpoints had a user that logged into them, or where certain things existed. And when I saw Tanium and its ability to bring that data back in the core platform and gather that data in minutes, and then be able to take custom action in minutes as well, it broke open the whole possibility in the incident response world. So 8.5 years ago, I joined Tanium, and I've moved up now. I'm the technical product manager for threat response. And everything in threat response we've done is to build organizations' ability to do instant response using the Tanium platform's real-time data and its flexibility and the ability to take action at scale. And that's what want to make sure we cover today. And we've extended that ability to take action at scale into automating the endpoint to take its own action against high fidelity threats.
Well, Thomas, I remember when I was hired in here, just for our audience, this is a fun fact. I was on the same team as a TAM with Thomas, and it's been fun to watch his career here at Tanium because he brings that real world edge of having lived cyber response, incident response, and he brings that to the product. And so I'm glad you're on the show, Thomas, to talk about these things that are things that you've wanted to bring to our customers for years. So for those who may have not used threat response before, let's start off just on the ground floor. What is threat response briefly?
Threat response is a tool to help you take advantage of Tanium's power and flexibility and allow you to gain visibility into your endpoints and use that visibility to create automated detections. Take those detections and turn those into automated reactions and remediations on your endpoint. Probably be easier to walk through it a little bit, but if we go to our overview page in threat response, we can go see here, we have alerts, we have response activity, we can directly connect to endpoints, we have saved evidence, we can analyze the context of different artifacts in the environment, we can hunt, and then we build our intel on top of Tanium's visibility. And if we look at our intel documents in Tanium, this is where we can start using that Tanium visibility across historical data. We have the most robust endpoint telemetry out of any product in the market. Live data, we can analyze that live data, within minutes, and then also data at rest on disk. With our index capability, we can go index hard drives, and we can then search at the speed and scale of Tanium for not just files in a specific folder with a specific name. We can say, does a file with password in the name exist anywhere on disk? Does a file with this hash exist anywhere on disk? So those three capabilities, files at rest on disk, historical data, and live data, are what we've built our threat response platform on, and that visibility is what we built our Intel documents on. We can look at different types. We have OpenIOC documents, STIX documents, Tanium signals, our proprietary detections, and Yara. rules as well. Again, one of the only platform I know of that can safely run YARA rules across 500,000 endpoints, um, throttled on the endpoint, and bring those to type of detections back. Once we detect alerts, once we detect malicious activity on the endpoint, we bring them back as alerts, and we can come back and gather data on that. And additionally, once we've identified an alert and we've detected malicious activity, go in and take action on that. And we can go and we can download the file, gather all the endpoint telemetry, gather forensic evidence from the endpoint, and we can quarantine the endpoint as well. Plus, any custom package, we can blind threat response. So we have the ability to tailor this. And again, the flexibility and power of Tanium means that we can tailor this for 0-day, targeted attacks, lateral movement, things that typically get past your typical security, AV, EPP, and EDR type solutions.
Well, Thomas, that's a really good overview. And again, that's just an overview, folks. And my favorite way to get you up close and personal with threat response is to come to Converge. You know, I take every chance I can to promote Converge. Come take our threat response labs. They're amazing. And you can do the capture the flag at Converge as well to get your hands on with threat response. Some great use cases. So Thomas, that's a great overview and a foundation. So what is this new thing that we're doing with these endpoint reactions?
Most people in security organizations that deal with automating security in their environment, specifically around alerts, have the issue where the alert happens on the endpoint, it comes back to a centralized SIEM, that SIEM then sends the data to a SOAR, and the SOAR then automates the reaction. And that's a lot of points of failure, and that is a lot of time that takes place when you have an intruder in your network. Endpoint reactions allow you to tie a reaction to an intel document on the endpoint itself so that the endpoint immediately takes that action without any communication necessary back with your SOAR, your SIEM, your Tanium platform. So you can take any of our customizable intel documents, YARA, Tanium signals, OpenIOC, STIX documents, to identify any threat you have in your environment and tell the endpoint to immediately kill the process, delete the file, quarantine the endpoint. And actually, that is just the tip of the iceberg for what reactions we're going to allow customers to do in the future.
Wow. I'm just thinking there's probably some junior analysts watching this. Could you define those terms, SIM and SOAR, real quick? Because I know we use those terms all the time. Some people might not be familiar with those terms.
SOAR is a automation platform that for security, and the SIM is an information gathering platform for security. So typically, SIMs are what gather all the telemetry, not just from your endpoint, but from your AV, from your firewall, from your network intrusion detection systems. And at that point, you try to take all that data and correlate it. And oftentimes from those correlations, you may want to take action, and your SOAR is your method for automating taking actions on the data collected in the SIM.
Yep, and Tanium has always been a data source that you can pull into your SIM, that back-end collation of all your data sources, and then an API reachable platform for you to then go back out to those endpoints and take action on them. So we've been working in this space for a long time, but what if I hear you saying this, if I'm hearing this right, is we can skip that big loop of the actual, all right, the event happens, then it has to get collected into a database in the SIM, then it has to trigger an automation, which then goes back to the endpoints. And that loop can take minutes to hours. Mm-hmm. So you're saying now right there on the endpoint, if we've identified, yes, this is the bad thing, let's go ahead and either fix it or disrupt it. Am I tracking there?
Exactly right. Customers asked us for the ability to say, I know this is bad. I want my endpoint to stop it immediately. They wanted, and you used the correct language, attack disruption. Different OSs and different technologies have the ability to use things like AppLocker to stop an application from running by name or by hash or to do other things. We created endpoint reactions, again, to kill the process, delete a file, or quarantine an endpoint across all three OSs, Mac, Linux, and Windows, the threat response supports. And because it happens immediately on the endpoint, it is specifically centered around attack disruption and real-time remediation. If an attacker goes and they start a process 1 time a second, 3,000 times on an endpoint. If we have a reaction for it, we're going to kill it all 3,000 times immediately, so that they cannot get traction. They don't have to wait for something to be automated through a SIEM and SOAR. It immediately disrupts this attack that this organization is facing, no matter what that attack is.
Wow. And that's really, I mean, number one, that's amazing capability, but also cross-platform across Windows, Mac, and Linux. And we know each one of those OSs have their own unique nuances, but that's remarkable that we can do that cross-platform, real-time detection and response. And I love that term, attack disruption, because it's like we're right there in the weeds, battling it out with the malware as it happens. I'm really curious, what are customers saying who've gotten to use this so far?
We've had customers waiting for this, and the customers that are using it currently, they're finding all sorts of use cases for this. The obvious ones are, I know this is malicious in my environment. I don't have time to wait for my AV or my EDR or my EPP to create a signature for it, or it's not flexible enough for me to customize this. I can't kill all instances of this binary in my environment, just specific ones. And so they're using it for attack disruption on very specific targeted type attacks. And then we have others that are using it for ops use cases, where they have certain error files that they need to be cleaned up and then preserved. Because when we delete a file, we also have the option to preserve it, so you can have that as evidence later and analyze it. So they're using this to clean up error files in their ops use cases as they occur, making copies of those, so it's not disrupting their point of sale systems. So we've already had customers take this and use it for both security and ops use cases right out of the box.
That's the fun thing about being in the software business all these years is, we come up with some really good use cases that we're automating and fixing for people, and then the customers take these things and do even more things we never even dreamed, and it's great to see that stuff coming back. Well, we've talked about this enough. I think it's about time to get into a demo. Why don't you show us what we built?
We'll give a couple of easy examples here. We're going to use some really evil malicious software. We're going to start out with Notepad. We're going to, have this running in this environment. We're going to pretend it's doing bad things. Now, why am I using Notepad? Number one, it's a Windows signed binary. And I want to show an example of how you can kill Windows signed binaries if you wanted. And number two, it's visual for this environment. But if we have Notepad running, and let's assume this is malicious, consider it a malicious file that's called Notepad. We can go back, and I've created an Intel document that simply looks for a process path ending with notepad.exe. I've attached a reaction to it that tells it to kill the identified binary. Now, the nice thing is, if I went in and I created another one, I could put the hash of this process here. And I could kill process by hash. So no matter what the attacker named it, it would kill the process by hash. I can kill it by any of the artifacts we have that were allowed in our detection methods. But I have this, it's going to kill the binary. And notice we have to actually check a box to say I want to kill Windows only signed processes. We won't kill Windows signed processes, Microsoft signed processes on Windows, or Apple signed processes on Macs by default. But in this case, we do want to kill that. And this is also in audit mode. If we're going to kill processes and we're going to delete files, let's make sure they're doing the right thing. So we start all of our reactions in audit mode so that you can go through, deploy this, come back and look at the data and make sure that this is all correct. You've crossed your I's, you dotted your T's, and you're ready to turn this in active mode, and then it will start protecting your environment. We could deploy this Intel document to the endpoints, to all our endpoints, and it would automatically kill Notepad as soon as it starts up. We'll show you an example of that coming up. But if I needed to do this on a one-time basis, and I don't want to kill Notepad across my entire environment here, so I'm just going to do it on my endpoints. And in this case, remember I said that this was in audit mode. That will just tell us what it would do. It won't actually take the action. I can override that for my on-demand scan. So I'm going to run this and let this kick off in the background. And we'll watch in a minute or two, we'll see Notepad be killed in this environment as it's deploying this package down to the endpoint, running that Intel, and taking that reaction on the endpoint. I have another one that I created for WordPad, and that's so evil, Microsoft's getting rid of it. I've actually deployed the reaction for WordPad. So just to show you, if we look back at our Intel documents, we have a definition, process path ends in WordPad.exe. We have a reaction to kill the binary here as well. Now this one is deployed, and notice it's in active mode. The beauty of our reactions is that when that Intel is deployed, it immediately kills the binary upon seeing it run in the endpoint. And no matter how many times I want to run it, it is going to kill it every time it sees it in that environment.
Man, this is great. Anytime that hash or executable path fires up, we're going to kill it. And I know we're talking about this in real time. Let's flip back there because I want to see the notepad because it's going to die any second. And there it goes. It just went away. And even though it took a few minutes, in this case, this was an on-demand. It had to get the content out to all the endpoints for the notepad example, right? But the WordPad example was already there. So as soon as it sees it, it kills it. But we can on-demand then run these actions across hundreds of thousands of endpoints if we wanted, which would have made your job a lot easier back in the day.
Yes, exactly right. And that's a good thing to point out is that on-demand scans are one-time events that you want to do in the environment right now for all online endpoints. And they can be, I want to disrupt this immediately. And then let's see what results we get back from that. And then if I get back those results and that looks good, then I can deploy that intel. And, and then once it's deployed, you saw how fast we'll immediately kill those binaries once they start up on deployed intel.
Which is great in a cleanup example when you just you're trying to get your arms around it. You send out your first batch. Okay, just kill this. We know it's bad, no matter where it is, and then that gives you enough time maybe to play whack-a-mole until you build your action that'll just go out there and keep it killed. Yeah, that's great.
Just to show you, when we look at the alert that we just got from that, it tells us that reaction and what process we killed as well. So we identify this, we tell you that it's successful or not, and we give you all the details of what we did on the endpoint.
Oh, so wait, hold on, before you close that out, look at that, mouse over that path again, because I think this is interesting. If you're telling this to kill a hash, no matter where it is or what name is, you can use this to see, okay, where is it showing up in the environment and what path and name.
Absolutely. And again, it doesn't matter what path, it doesn't matter what name it's using if you're doing it by hash. If you don't mind, this is a good time. And let me show you the flexibility of our Intel. Because again, Tanium's flexibility is where it really shines. And if we look at our Intel, our Tanium signals, we can do things based off file path and operation. And look at all the objects we have for process: path, hash, the command line, user, group, parent path, parent command line, ancestry, signatures. So you could kill certain things by name and not having a signature, or having a signature by what their parent is. We could go and we could actually kill all processes for a certain user across all 3 operating systems that we wanted to disrupt until we could reset the password for that user or something of that nature.
So I just saw that example recently with a customer that had an incident, and it was based on they know that the malware was using this one particular user ID across multiple systems, and they knew it was malicious, anything that ID was running. So I mean, that's a great example, and these can be combined as well.
Yeah, registry, network, image, and then if we look down at our OpenIOC's formats, we can take reactions on any of these: DNS, event logs, file items, network items, process items, registry items, services. The whole power of this is that you don't just have to specify a hash. You don't just have to specify a file name in a certain path that's a certain size. We can use any and all pieces and disrupt attacks based specifically on what's going on. If you don't mind, that leads me to another example that I like to show. That's, let's say you're facing a PowerShell attack. Can you imagine what would happen if you went and tried to kill all PowerShell in your environment by hash or by path? That would probably be pretty disruptive for most environments. The attack I want to talk to you about right now that really shows the flexibility of using all of those different pieces and parts of our visibility to create alerts and endpoint reactions assume you were facing a PowerShell attack where you couldn't go and kill PowerShell throughout your entire environment, but you had a long-running PowerShell reverse backdoor. This is an example of a fake PowerShell listener on port 999 that's going to be running in this environment. So when we kick that off, we can see that it's running right here. But notice we have all these other PowerShells that are legitimate PowerShells in this environment. So we can't go in and kill by hash. We can't go in and kill by process name. We need to kill just the PowerShell with this specific activity. To demonstrate that, what we've done is we've created a Intel document for PowerShell reverse shell in the command line, and we created a definition. The process path ends in PowerShell.exe, and the command line contains execution policy restricted, 999 is the port, and the system net sockets TCP listener. So we're specifically looking for only these PowerShell commands, and we want to leave the rest of them alone. And we have a reaction here in this case, which kills the process and quarantines the endpoint. So I wanted to show that you can stack these remediation actions into remediation policy. So I can kill the process and quarantine the endpoint. I could also delete files if I wanted. But if I go now, this is obviously not deployed. So we'll do an on-demand scan. And if that is successful for us, we can deploy it. In this case, I'm going to override the mode and make it active. And we're going to let this run. And if we sit and we watch this PowerShell and all the others in this environment, in about 1 or 2 minutes, that package will be deployed to this endpoint. Intel document will run. It will notice this specific PowerShell, and it'll kill only that PowerShell.
And then we'll also notice that the quarantine kicks in, and the ping in the background should stop as well.
That's correct. And there it goes. So notice that specific PowerShell is killed. All the rest remain healthy and fine. So we've, again, disrupted this specific attack. We could then deploy this Intel document to the endpoints, and it would shut that down immediately after it started up, just like we did for WordPad in our example earlier. And the quarantine is kicked off in the background. Quarantine is going and applying all of our rules, and it's testing communication with the Tanium server. And then once that has been verified, you'll see the quarantine package and the pings stop happening. It kicks off the quarantine immediately, but the package sometimes takes a minute to run.
And there's the quarantine. Very good, Thomas. And so we've just stacked two simple things here. I can only imagine in a complex real world scenario where you've got the 0-day flavor of the month happening. This gives you a lot of flexibility because that dwell time, I know you've talked about in the past, is that when it can propagate, this is like stopping the poison ivy before you get the itch, right? I mean, this is great.
As an example, as a reminder, just of the 3 initial reactions we have, is we have the ability to kill the responsible process, we can quarantine the endpoint, and we can delete the file identified by the endpoint, and we have the option to preserve a copy of that file in the Tanium client folder so that you can preserve that for analysis and review later. We also have the ability to create a list of files. If you just wanted to do cleanup, no matter when something was detected, I want to make sure these files, these 10 files, these 20 files are deleted no matter what. You can create a list of files as well that will automatically be deleted. I do want to point out with delete files identified by Intel, we can use all of our Intel identifying features for file, for extension, for name, for folder, for hash, for size, to identify what files you want to be deleted. So no matter what their name is, because I know a lot of malware will use random names, but as long as you can identify a few identifying features, we can create an Intel document to automatically take care of those no matter what their name.
Man, this is great. And I know at the front you said this is V1. All right, this is live. This is already available. Yes. But what's because you're kind of teasing here for the future. What is there anything that you can tell us about what you've got planned next?
We have Quarantine Workbench, which is coming out very soon after this. As you mentioned, this is already in GA, our general releasing Tanium Cloud, and it'll be in the November 2024 semi-annual release for on-prem. Quarantine Workbench is coming out, and it'll allow you to select what quarantine policies you want to use on your endpoint. So you can have one for internet type incidents, and you can have one that's a full quarantine, except I want my AV server, my forensic server, my evidence server, and Tanium server to be able to talk to it. Whereas most quarantines of the products are all or nothing. We allow you to customize what you want to access there. You can specify what policy you want to use in your reaction. The other two big ones customers have been asking for that we are listening and we're working on delivering is they want to be able to do registry remediation here as part of their steps. And then they want the ability to write their own custom PowerShell, bash type remediations. And so we're going to give them the ability to write custom Tanium packages for their remediation activity attached to reactions. So not only can you use Tanium's full flexibility for identifying what to act on, because the Intel document says, this is what I want to act on. The reaction says what I do. You'll be able to customize what you act on, and you'll be able to have the full Tanium customization for what activity you want done and what remediation you want to take place and what attack disruption you want to happen in your environment.
Man, that's beautiful. Wow. Such flexibility that's coming soon. And you mentioned, just to be clear for everybody who's watching, so if you're a cloud customer with threat response, this is live for you today. If you're on-prem, you'll be getting this in the November semi-annual release update. As always, we recommend you test things in your environment. Make sure you test with a small computer group first, right? All those typical things about deploying new things in IT, we've all learned the hard way. So we recommend that you do that first. And so, Thomas, when let's say I'm a cloud customer, it's live in my threat response environment. Is there anything I need to do to set up or configure this to get it working?
It is there and it's ready to go. Some default reactions set up for you. You can create test Intel documents, but what you want to do is when you edit your Intel document, you simply select what reaction you want it to take place. Just like you mentioned, you always test this, you run it in test user groups, do everything else. You always start your reaction in audit mode, and then it will report back what it's actually doing in your environment without taking those actions. So as long as you create an audit mode, you're not going to hurt your environment. You can test to your heart's content, make sure that it's doing the right thing. We just talked about making sure that you start this in audit mode, so it tells you what it's going to do rather than actually taking the action first, so you can validate that in your environment. And when you do that, you'll quickly and easily see reactions will be set to audit mode. It will tell you exactly what they would have done without actually taking that action, so you can validate everything before you make it active.
Thomas, this is compelling capability. Like we said at the beginning, and we're constantly innovating, trying to make folks' lives easier. Anything else as we wrap up you want to make sure people take away?
This is extremely powerful, and anytime you face any sort of targeted zero-day internal lateral movement type of attack, you can go and create reactions to immediately disrupt those attacks and have real-time remediation in seconds. As we've mentioned, customers have already found IT use cases for these as well. Let us know what additional features you would like us to add for these endpoint automations. Keep an eye out for other things we'll be adding in the future. I've talked with the Guardian team about this. We want to learn, this is down the road, but we want to be able to deploy and send out intel around Guardian with reactions that customers can automatically have and turn on in their environment for zero-day and targeted, based attacks. So you'll see us integrating this and expanding this throughout other places in Tanium as well.
That's great news. And so if you're watching this show on the Tanium YouTube channel, click around in that Tanium Tech Talk playlist and look for the Guardian video also, which Thomas referred to, so you can tie those two together. That's going to be really slick. I can't wait to see that drop. So there you have it, folks. Amazing capabilities for attack disruption in the Tanium Threat Response that you know and love. We continue to add value here. And as always, in the show notes below, there are some links for you to our Tanium Resource Center articles, to the docs, and resources there to help you get going with this capability. And like we said, if you're a cloud customer, it's already live for you. So go ahead and jump right in, start in that audit mode, get out there and test it. And hopefully we can begin to see, we'd love to hear back from you how much this has really helped you save time. Hopefully, like we said on the Guardian show, get you home to your family earlier when these things happen. So that's it for today's episode of Tanium Tech Talks. Until next time, go Tanium.